Alright, folks. I thought I'd do a tutorial on how to target genes for crossbreeding, selective crossbreeding. I have 3 strains of corn here, and I'm going to target one to inherit genes that I would prefer. Alright, let's turn the lights on here. Okay. I have several planters set up. This is my grow line for growing crops and also for growing things that I want to find better genes for. When you plant stuff in a planter, this is a 9 slot planter. It's three rows of 3. This farm block setup I got from let me bring it up here. Here we go. I got this from Melanik. He has a nice farming tutorial on YouTube, and I found it quite useful for figuring some stuff out. But other things I had to figure out on my own, because he doesn't go really deep into depth on how genetics work. So I played around with it for a while until I figured it out. Okay, let's go to the basics here. When plants crossbreed, they got to be right next to each other, one cell from each other. If they're separated by a space, they will not crossbreed. So it's diagonally one square, or horizontally or vertically one square. The plant next to them. So whatever surrounds them, and it will jump between planters too. So if you have one planted here and one here, they will crossbreed across this gap. So that's the whole basic concept of having a farm block, is for doing mass crossbreeding between, like 4 different gene types for mass crossbreeding and trying to get the best out of what you have. What I'm going to demonstrate is targeted crossbreeding. Taking one plant, which I might as well plant now. Okay. This is my target plant. So I will need to plant it first, because growth plays into this hugely. Okay, so I want to make sure I've got the right one here. Y. Okay, that is my target plant. So I will plant it and let it grow. This is the plant that is most important that it be at the crossbreeding stage, if you are going to take genes from other plants around it. So now that I've got this other plant here, I can use it as a visual aid. See, if I planted one right there, it would crossbreed with this. If I planted it here, it would crossbreed with this because they're one cell apart. But if I planted one in the corner here and one in the corner here, it wouldn't be able to crossbreed because there's a cell separating it. Also, if I went and planted 4 in each corner and nothing in the middle, they would all be separated by enough that they wouldn't crossbreed. And this comes into play when you're targeting a plant to crossbreed what genes you want to go in it. Okay, now that's got to set and cook for a while, so it's going to be. I'm going to have to speed up time when I get to doing that. All right. Now I'll take these and set them aside. This is one of my control. These 2 I will use as placeholders for genes that I do not want to lose out of my target. And then this one here I will use to introduce new genes to my target plant. So I have 2 of those, and then I have 2 dissimilar ones with genes that I want saved in my target plant. Even though one of them is, this one here is the same as my target plant, but it has genes that I want to make sure are saved and not exchanged out. Okay, so I use it as a control plant. Alright, let me demonstrate how to keep them from crossbreeding. We'll throw out some seeds here. We'll say 25. Might as well. Okay, this is how I get to find the genes that I want to use for crossbreeding. Okay, see that one there? That's good yield. Y is yield, G is growth, H is hardiness, which apparently has to do with how much health you get back from the food when you eat it. Not anything to do with the resilience of the plant. Okay. That's 3G. It's going to grow fast, but I want to get rid of the hardiness because it really doesn't matter that much. Okay, so now I put 4 there. I can't put 1 here because it would be right next to that one. So on this planter, I have to put 1 here and 1 here. Those are poor genes. And then we can go back to 4 in this planter, because we're keeping them all separated by 1 cell. They won't crossbreed, so you get a pure gene of what it is when you plant it. So you can use this for finding good strains that you want to crossbreed in for better qualities in your target plant. Okay, that's enough of that. We'll let them set and grow. Okay, now fertilizer. Fertilizer works to keep your plant alive. I don't think it really... It affects growth, but not greatly. It's more useful for people who are forgetful that they're planting and growing, and they wander off to do a monument or get into some PvP or whatnot, and forget that they got stuff growing. Without fertilizer, if you walk away from your plants and they reach fruiting, get 100% fruiting, they will die and disappear. But if you have fertilizer in, that won't happen. It'll continue to use the water up until it's down to such a low saturation of water in the soil that the plant growth slows to almost nothing. But the fertilizer will keep it alive. I planted some stuff and forgot I had this farm block here full of berries, and I walked away from it, forgot about it, went to bed, come back 9 hours later, and they were all still alive. I was shocked that they were all still alive. But that's the usefulness of fertilizer, I think. It's more forgiving, helps when you're forgetful about what you're doing with the plants. Okay, where's this at? 22%. We've got to wait for it to reach at least 50 to 60% of sapling, because after sapling it will go into crossbreed and then into mature. So you want to make sure that this one's going to go into crossbreed before anything around it. Anything. It will pull from the genes from around it, no matter whether they're in crossbreed stage or not. But if you plant something that grows fast too early, it will reach maturity or crossbreed stage before your target plant, and it ruins the whole crop, because it will take the genes of your crossbreed, of your target plant. And then when this one comes in for crossbreed, it no longer has genes that it can pull from the ones that you're wanting to inject into the target plant. So growth is very important to pay attention to. If you've got a slow growing, high yield plant that you're wanting to inject growth genes into, or, you know, replace and add more yield to it, you got to make sure that this is ready to crossbreed way before any of the plants around it that it's pulling genes from. Okay. Now while that's cooking for a while, let me bring up this. Okay, whoop, wrong one. There we go. Okay, this is basically what's going to happen with these plants. Okay, so I've planted the 3Y WYW as my target plant. I'm going to get genes out of my gene donors, and I'm using these bottom plants as placeholders to reinforce the gene slots that I don't want to lose genes from. The way it was explained to me is a plant that goes into crossbreed will pull genes from the plants that are around it. Okay? And the majority of the genes that are alike of the plants around it will become the genes of the target plant. So, for instance, here, the first gene is YYYX. So obviously it's going to stay Y. The second is GGYY. Now, I've done this experiment 2 times, and they both came out the exact same. So I'm thinking that there is a dominance in genes, and Y is dominant over G, because you have an equal amount of G's and an equal amount of Y's. And it came out Y. Also, with H's, I had an equal amount of H's in slot 3 and an equal amount of Y's, and it came out Y. So Y must be dominant over G and H, yes. Now, for the 4th slot here, we've got 2 G's, we've got a W, and we got a Y. So that will make this a G. On the 5th slot, we've got 2 G's, 2 Y's. Y dominant over G makes it a Y. And on the 6th slot, we've got 2 Y's, a W, and an H. The Y's have the majority, so they will become a Y. What I found interesting about this is this one, the center plant, reached crossbreed first, which was what I wanted it to do, so that it would pull the genes from everything around it. This plant, when it reached these 2, which reached crossbreed shortly after this one went into maturity, these 2 stayed exactly the same. They changed no genes at all. They stayed exactly the same, so I was able to use them, get cuttings from them, and reuse them again for more experiments. Same thing with these 2 down here. They did not crossbreed at all with the center plant, even though it had already crossbred and had the genes. This wasn't the case when I tried doing this before with the same configuration, but I planted everything all at the same time, and the gene donors reached crossbreed way before the target plant did. They took on the W's. So it changed to YGHWGW. And it totally ruined my crop. So yeah, that's where I learned that you got to pay attention to the growth rate. You got to make sure that your target plant is going to reach maturity well before the donor plants around it. Okay. Back to here. Let's see where we're at on growth. We're still in seedling. We still got to go all the way up through sapling. So let me show you this clip from Melanic's video. I'll go inside here for a minute. And
Separate your seeds as much as possible so you are creating at least 4 different genetic strains. Now once you reach the point that your farm is full of different strains, start to combine them. Pair them up and intertwine the 2 planters in a checkered pattern.
The checkered pattern is important. You want to keep your genetic strain separated with a different genetic strain in between them, so that they are crossbreeding, not just reinforcing the genes they already have.
Here on out, it's survival of the fittest. Only take cuttings of the absolute best in each planter. Start the process again. Separate your strains and repopulate them. Then repeat the intertwine. If you continue to do this, you'll gradually improve your seeds more and more until they're ready to be merged into what I'm calling a super seed batch. So at this point, we've grown and refined our own 2 strains or more. Now it's time to bring it all together. Intertwine all of the seeds across your entire farm into the checkered pattern. Depending on how crazy you want to go with this, you can refine this batch and even reset the whole process with a far superior starting point.
Alright, so now about composters. Composters are great for getting fertilizer together. The best things to throw in them is horse poop, which, by the way, I gotta go collect. The horses poop once every 5 hours, the way it is set up right now by Face Punch. Each horse dung will give you 5 fertilizer. So that's my whole purpose of having horses, is just for the extra 20 fertilizer every 5 hours. We don't take them out very much. We usually fly. Alright, you want to spread your stuff out in the composter, so that, because it acts like a furnace, so it will make everything compost a lot quicker if you spread it out like a furnace. I gotta switch over to the web view again. Okay. This is Rust Labs. They have a lot of good information on everything Rust. These are the amounts of compost you get back per unit. So, corn, chocolate bar, small trout, and horse dung are your top 4. They're going to get you the most. But as you see, as you go down the list, you get lower and lower return rates. The far right number is vanilla stack sizes. Okay. Back to the game. Check. See where we're at. Okay, we're at 0% sapling. I need to wait until 60% sapling before I start adding in my control plants. And at that point, I can add in my quick grow gene donors, but I'm going to wait as long as I possibly can. So now it's just a waiting game. I'll fast forward through this part. Okay, we're close enough to go on ahead and add in our placeholder plants. Okay, I want that one right here. That's the same as our target plant. And I want this one right here. These are all slow growing too, so we're in no danger of them overrunning our target plant. The only ones we're worried about overrunning our target plant are the quick grows. And we shall wait until about 60% before we add them in. Okay, we are at 63%. Time to add in our gene donors. These will grow very quickly. They have 3 growth genes. And these have none. Okay, while we're here looking at this, note that my water content in my soil is below 9,000. And as you've been watching this grow, the water percent in conditions has slowly gone up. And from my observations, anywhere between 7,000 and 5,000 is a good area to keep your soil in for the best condition for your plants. And I'll now just sit here and we'll watch the magic happen. Time to fast forward. Alright, magic is about to happen. Another minute away. Now what we were expecting is the W to be replaced with a G and the NW to be replaced with a Y. Being as I've done this 2 times before and came out with the same outcome, I am expecting the same outcome. I'm learning this along with everybody else. I'm new to this, and I figured this was some useful information to give out. After we're done doing this, I have some pumpkins I want to work on, and I'll show you how I work it out on paper before I do it in the planter, rather than wasting plants. I will look at it and see if I have the proper genes to work with. We're getting ready to go into crossbreed. Now, I do not know for sure what the dominances are on the genes. I'm just guessing at this point. I'm going by what I've learned. And there we are. YYY, GYY. This is seedling still. This is seedling still. This is seedling. All of them are seedlings still, except for this one. And that's a successful gene injection. Okay, let's take a look at our pumpkins here again. See what we have. Anything that would be useful? No, it doesn't look like it. Nothing that I don't already have. I need more growth genes without the hardiness genes. Boy, that looks pretty. Okay, so we'll use this planter here. This has got 50 fertilizer in it. Okay, where did it go? Right here. Okay, this is what I got to work with. So let's go into our worksheet first and see which one are we going to use as our target. I think we should use this one as our target since it's got 3 Gs. I just don't know if I'm going to be able to keep them. So I guess let's find out. All right. Notebook. There we go. Okay. Now this was from the last one, so I'll go ahead and erase that. Okay, so we want to use YYYHYH as our HYH. 1, 2, 3, 4, 5, 6. Those will be our gene donors. And then we want to use X, G, H, G, Y, G as our target. And what I have for a placeholder, which I don't know if it's good enough, is HYH GYH. And we would want to use XGH GYG. Okay, now looking at that, it'll inherit the Y. Okay, let's come down here. So we got Y. Second one is Y, Y, Y. So that will be Y. Third one, H, Y, Y, H. And if we remember correctly, Y should take dominance over H, so we'll say Y. Okay, so third one, H, 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 or fourth one, G, G. I think that's going to be a G. I think growth takes over H. Y, 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 Y. So that's going to be a Y for sure. H, 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 G. So it'll be an H on the last one. So that's what we should come out with on our target plant, which is 4 Ys, a G, and an H, which, you know, I can live with that. That's better than 2 H's. 3 Ys, a G, Y, H. Yeah, 4 Ys, a G, and an H. Yeah. And if I wanted to, I could probably even refine that more by using the XGHGYG as a donor with a different control or a different placeholder. I'd have to work on it. Okay. I think that'll work. Okay, so all right, back over to the game. Let's see. I need 2 of these. 2 of these. And 1 of these. Okay, and this is going to follow the same rules as the other. The high growth ones are going to have to go. Ooh, yeah, they're the targets, so that's going to go first. This will even be better. These will definitely grow first, but I still want to delay the second one. Okay, I got an idea of what I need to do here. All right. So, the plant. See that? Is that the right one? Yes, that's the right one. Okay, plant this first. And we'll let it cook for a minute. But we won't have to wait as long. So we'll just let that grow for a second. That looks nice. That came out perfect. 58. These are about to go sapling. And these will be going crossbreed. And because they're separated, they won't crossbreed. And apparently they won't take on the genes of the one they crossbreeded with either for some reason. So I don't know exactly how that works, but wow, seed, you're taking a long time to grow for being a 3G. Oh wow, straight to seedling. Okay. We'll let it get 5% in. Next tick, I'll plant all the slow growing stuff. And then the last tick, I'll plant the other one that's exactly the same. Okay, so I want this one here. That's going to be another quick grow, so that's got to come later. let this one get to 30%, and then we'll add in the last exact clone of it. And we'll see how this experiment goes. Let's see if I can predict it right. Okay, and that's the last one to put in, and we let her cook and see how it comes out. Everything looks like it's staged good. This is at 40% seedling already. This is just hitting seedling. This is still a seed. These are still seeds. This one should easily get to crossbreed before anything around it. Okay, let's look at the water on this. See, we're at 98%, and we're at 69.24 on water for saturation in the soil. So, yeah, keeping your plants water at 9,000 is not good for your plants. It's going to affect your yield. And it will affect your growth rate too. However slight, it does affect it. I have 204 of these grown already. These clone out with four clones for every plant, so they propagate quite quickly. Also note how I have, this is a floor and a half up for my floor grates that I have my lights mounted on. That's because if you go like this setup, it works great for hemp, it works great for pumpkins, it works great for berries. But corn, on the other hand, when you place your light in the center of the box on each one of them like this, that center spot that hits the corn, it causes the light to go off to the side or glitch out and flash and strobe and do all kinds of weird stuff. So for growing corn, it's best to have it, especially if you don't like flashing lights. Yeah, go with a story and a half. It'll be better. This farm block setup, I set it up exactly as the YouTube video showed. Is I've got 3 sprinkler heads clustered together here to supply 4 planters. The only thing different is I went a little bit higher for my lights because I grow corn in here as well as everything else, and I don't like having the lights glitch out and flicker and do weird things. I have 4 barrels supplying all of the planters. You can do six sprinkler heads off of 1 pump. So I have 2 small water catchers here. It's actually, there's a 3rd one down there and a water pump down there. When you set your water pumps up, you got to have your water pump close to the source of water it's drawing from, and then you can pump it over however far. but if you go too far away from your water source, it won't draw water. And if you get your sprinkler heads too far apart, it causes issues too. But, so I have 3 reserve barrels full, 4 reserve barrels full right there. And then these are all hooked up to the sprinkler system, 20,000 milliliters each. So I've got 80,000 in reserve. I've got 80,000 tanked up ready for the sprinklers, and then 30,000 in the water catchers. Plus I have large water catchers outside around my base so that I can use my buckets or my jerry cans, water jugs, fill them up, and then just transport the water in and fill up the reserve tanks, whatever I need to do. Alright, we're getting ready to go into sapling stage. And these are looking good. These are all behind the curve on the growth. So this one will definitely reach maturity first for crossbreed. Oh, that's some frame rate lag. Sorry about that, folks. OBS just does not like me for some reason. Okay. So I guess we will go with a timed sequence right here, and we will watch this grow and see what the results are. Going back to fast forward mode. Okay, we're getting close. We're about to go into crossbreed, and we'll see what our results are. This is kind of exciting. I've been playing around with this for a couple weeks now. And I'm excited to know if I've got the right idea here. YYHGYH. That's not what I expected. YYHGYH. YYH. YH. Okay. So H takes precedent over Y? Okay. Well, we learned something there. We still got that's the same thing as that, just a different order. Yeah, that's not what I was expecting. Alright, let's go over what we learned here. Alright. Bring up our notepad here. Okay. So that was the results we expected. YYHGYH is what we got. Now, can we explain that? H, H, Y, Y. And that's an H there. So okay. Alright, let me look back at the MS Paint thing I got here. Now, there's one with 2 H's and 2 Y's. Why did it stay a Y? Unless the target plant has something to do with it too. That is the only thing I can think of to explain that. So that's 3 Y genes to 2 H genes. Let's try that on something else that we had. Is there anything else? Two. 1. G. G. I don't know. Maybe the target plant genes do have something to do with it too, but it doesn't explain why 2 W's, 2 G's there. Well, that's not an H though. 2 H's there. 2 Y's. 3 Y's. Maybe the target plant has something to do with it too. Okay. That's not as good as I want, but it's a learning experience, so I think I've got the basic ideas, but I'm missing something here. Okay. Well, that's about all I can show right now. I'll work at it more and see if I can figure out. I'll have to experiment more. And then see if I just need to find better genes to work with. It's just going to take more time, I guess. Alright, well, that's what I've learned so far on it. And apparently there's some things I need to learn yet. Y'all have a good day.